Hello there my friends, hope you all having a really good day. So we have come to the fifth sorting algorithm in this sorting algorithm series, and this algorithm is called the quick sort algorithm. So let's get started. So before we start with the quick sort algorithm, I would like to request you guys to watch all my videos till the end, because that is how YouTube recommends my content to a lot of people. So if my videos do not have enough watch time, then YouTube would not recommend it to anyone. So it would be awesome if you could watch the video till the end. So yeah, let's get started. So in quicksort, we are going to sort the elements in a unique way. So we are going to consider an element and call it pivot and put that element into its correct position, that is the position that it would assume in the sorted array, in the sorted list. So for example, if we take 4, when the list is sorted, the list would look something like this. So 4 will come at the third position. If you can see, the third index will be occupied by 4. So in quicksort, we are going to directly find this index and put 4 into it. So the easiest way that we can do this is by putting all the elements less than 4 to the left of 4 and all the elements greater than 4 to the right of 4. So if this is the case, then we can be sure of the fact that 4 is in the correct position. So how can we implement this? So for this purpose, let us consider 3 parameters, the pivot I and j. So let's consider I is a person who is top of the list and j is a person who is at the ending of the list. And let us consider the first element always as a word pivot. We can consider any element as the pivot element, but for this video, let me consider the first element as the pivot element. So we have got to put the pivot in the correct position. So this person I and this person j, they come to an agreement. So I says I'll keep moving forward and I'll find all the elements which are greater than 4 and I'll put them to the right of 4. And j says I'll keep finding the elements which are less than 4 and I'll put them to the left of 4. So how can we make I and j do this? So I says that I'll keep moving forward until I find an element greater than 4. So I keeps moving forward like this. And he says, when I find an element greater than 4, I'll stop. I'll stop at that position. Then you do your work, J. So J says, I'll keep moving backward from 3 onwards. And I'll keep moving and moving and moving till I find an element less than 4. So when I find an element less than 4, I'll stop. So when both I and J stop, I stops at an element which is greater than 4 and J stops at an element which is less than 4. So they say we swap our positions. So in this way, an element which is greater than 4 is going to the right and an element which is less than 4 is going to the left. So that's what we need, right? So I and J keep on doing this and I is always going towards the right and J is always coming towards the left, and they keep on doing this. And at one point, J crosses I, or in other words, I crosses J, then there is no point in moving further because I, which has to be in the left territory, has moved towards the right territory, and J, which has to be in the right territory, has moved towards the left territory. So, so if this case happens, then it means that all the elements which are to the left are less than 4 and the right elements are greater than 4. So in such a case, I and J need to stop doing their work and 4 is put into the middle of the list. So that's what we saw. If 4 is in the middle of the list, then it means that 4 is in its correct position. So in this way, quicksort is again and again recursively called till all the elements are sorted. So that's how quicksort works. And this process which we just saw now is called the partitioning process. So let's quickly look at how we can implement the partitioning process for 4, taking 4 as the pivot. So initially I is here and J is here. So first we advance I and I is moved over here. So I now points to 5. So we observe that 5 is greater than 4. So we need to stop. So I is halted over here. And now we advance to j. Now j, we observe that 3 is less than 4. So j need not move further, it should stop. So j is also stopped here. So what we do? We just swap the elements at I and j. So 3 comes here and 5 comes here. Next, we do the same process and I goes to 6. I points to 6. So 6 is greater than 4, so we need to again halt I and we need to move the control to j. J should be decremented. So j points to 2 now. When j points to 2, which is less than 4, j should also stop. So when I and j both are stopped, we need to swap. So 2 comes here and 6 goes here. Next, we again increment I. I points to 7 and 7 is greater than 4, so I is halted. J decrements itself and it points to 1. And when j points to 1, which is less than 4, j also halts. So when I and j both are halted, we need to swap them, swap the numbers. So 1 comes here, 7 comes here. So next, I is incremented. Now both I and j point to 7 and now 7 is obviously greater than 4, so I is halted and j is now decremented. J points to 1, 1 is less than 4, so j is also halted. And if you observe now, j has crossed I, so there is no point in swapping right now. So because j has moved into the left territory when it has to be in the right territory, so there's no point in swapping. And if you observe, all these elements are less than 4 and all these elements are greater than 4. So ideally 4 should come somewhere over here. But there is no index to hold 4. So what do we do? The best thing we can do is we can just swap 1 and 4. You see what I did there? We just swapped 1 and 4. So let me just write this. So 1 comes here and 4 comes here. So now what we did was we swapped 1 and 4. So these elements are now less than 4 and these 3 elements are greater than 4. So 4 is surely in its correct position, what it would assume in the sorted list. So we have got one element sorted. Now how do we sort the other elements? Let me just erase this. It's really simple. We call the partitioning algorithm for this part and the partitioning algorithm for this part. So next, after that, when this part gets sorted, we'll call the partitioning algorithm for the 2 elements and 1 element and so on. So we shall be recursively calling the partitioning algorithm and the list is sure to be sorted. So let's quickly write the pseudocode for the partitioning algorithm. So let me call the function as partition and let us pass 3 parameters, that is the array, low and high. You may choose not to pass low and high, but for understanding it's better if we have low and high. So basically low will be the first element and high will be the index of the last element. So we now have the partitioning function and first we are going to assign the values for I, j and pivot. So first I will be low and j will be high and pivot is not the index but it's the element, so it will be array of low in the starting. So this is how our 3 parameters are going to be. So we saw that I is going to be advancing, so we'll have a while loop for that. So while I less than pivot I plus plus. So when I is less than pivot, or we can include a less than or equal to here. So if I is less than or equal to the pivot, it keeps advancing. When it finds an element which is greater than pivot, it stops. It stops advancing and we proceed to j. So while j greater than pivot, we keep on decrementing j. And when j finds that an element is less than pivot, it stops. And when these two stop, I'll write the code over here, remaining code. So when these two stop, we need to swap the elements in their positions. Correct. So swap array of I, comma array of j. So we're going to swap them. So when are we going to do swap? We are going to swap only if I is less than j. And I guess you guys would know the reason for this, because we told that if I passes j or j crosses I, then there is no point in continuing to increment and decrement I and j respectively, and the process needs to stop. So this is how we are going to do it, but we are missing out a point. So now what this function is going to do is, I just stops when it finds an element greater than 4, j stops when it finds an element less than 4, and they swap, and that's it. That is the end of the function. So that is not what we want. We want I to continue incrementing and j to continue decrementing till I does not cross j or I becomes greater than j. So for that we'll need a while loop here. So while I less than j, meaning till I is less than j, you keep doing this process. And when I becomes greater than j, just come out of the while loop. The reason that we have the same condition here and here is because this condition is used to keep the program running till I is less than j, while this condition is used to do effective swapping, because after we execute these two statements, if we find that I becomes greater than j, then there is no point in swapping the elements at I and j respectively. So that is why we have this and this. So yeah, okay. Now when we come out of this loop, there is one more thing which needs to be performed. We need to swap the pivot element with the element at j. Since we want the pivot element to be in the middle, so we just swap array of j and pivot. And one last thing that we are going to do in this partition function is we are going to return the value of j. So this returning the value of j will become clearer to you when I write the quicksort function. So let me quickly write the quicksort function. So let me call this function quick underscore sort. So let us again pass the same three parameters through this function: array, low, and high. So this quicksort function is basically going to call the partitioning algorithm and call itself recursively. So firstly, we'll be calling the partitioning algorithm. So partition, array, low, and high, just like that. So when the array is passed through quicksort, the same low, high, and array are passed through the partitioning algorithm. So then we need to call quicksort recursively for the left sublist as well as the right sublist. And here is where j comes into the picture. So j helps us in identifying the left sublist. So low will be low and the last element will be j, because we want the left sublist till j. So that's why we are calling quicksort here. And for the right sublist, we again call quicksort. So here in place of low we'll have j plus 1, and in place of high we'll have high. Okay, I'm sorry. So you need to include a j is equal to here, because this j that we are using here is this j. So this is the j that we are going to use. So this j contains the value which is written by partition, which is this j. So that is one thing which I forgot. So yeah. And if you notice carefully, we are going to execute these set of statements only if low is less than high. So if low becomes greater than high, then that means there is no point in executing these statements, because in the last, if you observe, we'll also be calling the partitioning algorithm for the single element, and when we have a single element, then there is no point in partitioning this element. So we are not going to execute these statements for a single element. So that's why we need to include this low less than high condition over here, so that the program works perfectly. So that's it for this video, guys. Thanks for watching. Bye for now. See you in the next video.